solution. Now, the first thing we do is to have variables to represent these two types of liquids. So we shall say, let the number of liters of 30% acid solution used be equal to X, and let the number of liters of pure acid solution used be equal to Y. These two will lead us to the first simultaneous equation, which says that X plus Y is equal to 28, meaning when we take the number of liters of this solution that we use plus the number of liters of the pure acid that we use, should be equal to 28 liters that we are interested in making or obtaining. Then, now of these 28 liters, what does acid constitutes? Acid constitutes 40% of these 28 liters. So how much, or what is the volume of acid in these 28 liters? We shall take 40% multiplied by 28, and that's 4 over 100 times 28, giving us 11.2 liters. So we can as well say that of these 28 liters, 11.2 liters constitute pure acid. Then the volume of acid in these X liters will be 30%, because we are told this solution consists of 30% acid. So 30% of this number of liters we have used will be equal to 30 over 100 times X, giving us 0.3X. As for this one, we are told it is pure acid, meaning it's 100% acid solution. So that's why we are saying the volume of acid in Y liters of pure acid will be equal to 1 times Y, giving us Y. Then these two will lead us to another simultaneous equation, which says 0.3x plus 0.3x plus Y is equal to 11.2, meaning the volume of acid in this 30% acid solution, which we have calculated to be 0.3x, plus the volume of acid in this pure acid solution, which is Y, should give us the total number of liters of acid in these 28 liters, which is 11.2. Now, these are the two simultaneous equations we need to solve to get the values we want. So we have the two simultaneous equations down here. I've decided to solve them using substitution method, by substituting equation 1, and we shall make Y the subject of the formula. So that's what I've done. I've taken X across equal signs. So Y is equal to 28 minus X. Then after doing that, then we take the second simultaneous equation where we see Y, we substitute or replace it with 28 minus X. So that's what I've done here. I've taken equation 2, and then I'm replacing Y with 28 minus X, and that's what I have, 0.3x plus, instead of us writing Y, we write this, should be equal to 11.2. Now, opening the brackets gives us 0.3x plus 28 minus X should be 11.2. Then collecting like terms, we have 0.3x minus X being equal to 11.2. Then we take 28 plus 28 across equal signs. We shall change its sign to negative 28. This simplifies to 0.7x, because this is like 0.3x minus 1x. So that gives us negative 0.7x being equal to, when you subtract this, you get negative 16.8. To get x, you divide both sides by the coefficient of x, which is negative 0.7. You divide by 8 on both sides. That gives you x being equal to 24 liters. Remember, x was representing the number of liters of 30% acid solution used. And that is actually the answer for the number of liters of the 30% acid solution we shall be needing. we have not gotten y, so we continue and say take any of these equations, either equation 1 or 2, where you see x, replace it with the answer we have gotten for x. So I've decided to take equation 1, and then I substitute 24 here. So we shall have 24 plus y is equal to 28. I've substituted 24 here, and then take 24 cross equal signs. We have y being equal to 28 minus 24. And when you do that, you get y is equal to 4. So that means then we shall need 4 liters of pure acid solution, because that's what was represented by y. Therefore, we shall take 24 liters of the 30% solution as we found here, and then we mix with 4 liters of pure acid as we have found here. Thank you.